Welcome everybody to another SkyCiv tutorial. Today we'll be walking you through the strut and tie builder, how you can use it, how it can help you build grillages very quickly from your structural analysis models in SkyCiv Structural 3D. So this is a built-in feature, it's automatically available to all of our users, and it incorporates a lot of the New Zealand recommendations from the 3101 in how you can generate diaphragms using the strut and tie grillage system. So the software will allow you to automatically turn your plates into these grillage models. And today we're just going to explore how easy that is to do and how you can do that in the software. So I'll start off with a sort of large scale model. I've got a lot of grid lines set up. But yeah, you can see there's slabs and plates built into the model. So that's what we're going to turn into the grillage. So I'll just turn the grid lines back on. I will highlight one of these levels, because often you don't want to introduce the grillage model on an existing structure. You'd want to potentially open that up as a new model. So I can just right click, open up new model, and yeah, then create my grillage from this single plate. So to do that, I will go to under plates, and then I can click Strut and Tie Builder. Alternatively, I can toggle it here on the right panel, and also pin it to my taskbar. So if I'm going to be using that feature quite often, I'll just pin it to my taskbar and use that. It's much easier to access it that way. So I've got my plate. I will now select that feature, and here you can do floors. So you can select floors by elevation. Obviously this is at ground floor 0, so I'll just leave that as 0. You can do wall planes as well, so you can pick an X or Z axis and coordinate system if there are any walls in your model, or you can just simply put in a plate ID if you want to control which plates, and you can comma separate those for multiple. But for now, I've got my Y equals 0 floor, and I'm going to turn that into a grillage. So the steps to do that are quite easy. The grillage max spacing is default to 1 meter. I think that is one of the recommendations in the New Zealand standards. My topping thickness has just been taken from the slab thickness, but obviously I can control that from this input. The sections I would leave blank. You can select existing sections, but the tool is designed to auto-generate the width based on the recommendations of the New Zealand standard, which is 0.75 times the grillage spacing, and for the ties, and then for the struts, it's 0.53 times the max spacing as well. So you can control those. We can review them after we've built the strut and tie model to show you exactly how that gets generated. But yeah, those sections will get auto-generated based off your grillage spacing. We can add supports, so we will put in, you can put in a fixed vertical support or a spring support, and yeah, you can control the stiffness of that spring in the Y direction. And then you can also add lateral load. So, and these are optional inputs, but I will put in a lateral load of say 100 kilonewtons and say 150 in the Z, and this will distribute all the nodes that are generated from the grillage. It will distribute this force across all of those nodes. And then you can control the name of the group. I'll just leave it as EQ, which will then create 2 load cases, EQ_X and EQ_Z. So I'll go ahead and generate the diaphragm grillage. So it's going to create the sections for me, and then it's also going to create the grillage. And I'll just toggle off the loads. I can just do Shift L and Shift S for the supports, just so we can see a clear image of the grillage. And what you can see is created some strut and tie elements that would be pinned in terms of the ties. And yeah, you can see it's filled the space quite well. It's taken in account any openings that you have in your slabs, and also diagonal diagonal plates. It's done as close as it can with that grillage limitation, but then obviously you can control or complete out the angled parts of your plates. But for the most part, it's filled the area really well. It's used that max grillage spacing of 1 meter, and saved me a lot of time in my modeling. If I had to generate this manually, it would obviously take quite a long time. So I can also redo, so I can undo that last generation, or I can control my spacing here and adjust it and redo it. So you don't have to delete them all and start again. It'll just automatically regenerate, like our mesher does, for instance, for the plates. What it's also done is toggle the suppression on for the plates themselves. So the plate is still there. So if I say set this and I'm happy with that and continue, my plate is still there. It's just been toggled as suppressed. So I haven't lost that information. It's just been turned off the analysis. So I can run an analysis without that plate being there, because obviously the grillage is replacing the need for that plate. Looking at some of the loads, so we've created two sets of loads in either direction. I can come here to my right panel, and let's just turn the color on, might help things. I can see I've got my EQX and I've got my EQZ in the different directions, and that 150 kilonewton has just been divided by all the nodes across that plane. In terms of supports, so the supports have been added as spring supports with that stiffness that we entered earlier. And yeah, you might want to introduce some supports in the X and the Z direction, obviously because we've got loads in that direction, but we have no restraints in those. So just for the purpose of making the analysis work, I'll just put in a fix in the in the X, and the Z for that node, and maybe a node out here. Do the same. Obviously, you can fully control where you're applying those restraints, those lateral restraints, but I'll just do that for example's sake. And then finally, the sections that were generated. So this is obviously a very important part of the process, but the tie has been generated automatically based off the grillage. So it was 0.75. The spacing was 1,000 millimeters. So that checks out. It's 0.75 times 1,000, which is 750. Similar, the strut is 0.53 times 1,000. So we get a 530 millimeter width in the struts as well. So from there, we can go ahead and solve and just sort of review some of the results. So I can skip the auto repair. And have a look at some of the results. Let's have an axial. One thing I did forget to do, actually, I'm just going to, maybe I can look at the, my load combinations. I didn't specify a load combination for the EQ and EX. So I'm just going to turn both of them on. I'll leave self-weight on. So I just had to turn on the EQ and then we can just control that EQX. Because I transferred from my existing model, it would have transferred. I copied from an existing model. It copied all the load combinations from this model. So I'm just going to adjust those load combinations and rerun that. Okay, so some members have been removed because they're tension compression only. Sorry, and let's have a look at some axial results. So obviously, it definitely matters where you put your restraints, but just to sort of show you some of the results that you will receive, and you can see some of the axial loads within those members. You can create groupings as well. So combining this with groupings, you can then group the struts into one group and the ties into another, so you can sort of isolate those results. But I can see some of the results coming through from my strut and tie analysis. And that pretty much covers most of the tutorial. In this example, you can see a fair few different cases. I can also show the walls, how you can control the walls, or how I just use the plate IDs as well. But you can see I've got all my X in X equals 0, and it's automatically detecting where I do have plates. So it's picked up that is a plate there and that one there. I can also do in the Z direction. So if I want to do, say, plate 31, I can find that location and generate the grillage from that as well. So it does work in both planes. Obviously, the most common use case is a slab. But yeah, it does work in plates if you have shear walls or things like that. So I hope that tutorial helps guide you through how to use the strut and tie builder. We look forward to hearing your comments, and if you have any questions, feel free to reach us on the live chat. We're always available there to help you with your models. So thanks a lot, and see you on the platform.